Optimization. The goal of optimization is to find the extremes of a function on a given range. In a basic optimization problem, we're looking for the absolute extremas. So in this given interval, we're looking for the absolute maximum and absolute minimum values. So to give us some visual aid on how what these terms mean and what they can be used for, here we have a graph. This graph, it curves a little bit, it peaks, then here at +2 it increases positively upwards, and then here at -2 the function decreases negatively downwards. So if we're looking for the absolute maximum and absolute minimum values, we would take as our absolute maximum, we would say that at point 2, since it's increasing infinitely upwards, that would be our absolute maximum value, or our greatest value of the interval. And at -2, since it's decreasing infinitely, we would take at -2 that point to be our absolute minimum value, since it is going down negatively. So there's a little visual aid for you for looking at a graph. Now what we're going to try doing is we're going to be given a problem and an equation without a graph, and we're going to have to find the absolute maximum and absolute minimum values. So here's our problem, and to find the maximum and minimum values of this function, we're only going to be interested in the endpoints of the interval, which are, in this case, are -4 and +2. So those are the points that we're interested in. And we're also interested in the points in this interval in which the slope is equal to 0. And these points at which the slope is 0 are known as critical points. And to find critical points and to find the slope of any certain points, we'll be using the derivative. And you're all familiar with the derivative, but here's why the critical points are important. So here we are back at our graph, and the reason that critical points are important for finding absolute maximum and minimum values are because since the slope is 0, these points most likely will be at the very peak of the curves of these functions and these graphs. So potentially they could be the maximum and minimum values. Like if we took away these parts right here and just considered this curve, these points at which the slope is 0 right here at the very peaks of these curves, those could potentially be the absolute maximum and absolute minimum values, and that's why we need to consider the endpoints of the interval and the critical points, the points at which the slope is 0. Back at our problem with our interval of -4 and +2. And so now that we know we need to find the critical points, we need to first take the derivative of this function. And if you do the work correctly, you'll get this as your derivative. And we can actually factor that to get 6 times t plus 2 in parentheses times t minus 1 in parentheses. And now that we have this, we can find the points at which the slope of the function equals 0. So since we have this, we'll get -2 and +1. Both those points in this function will have a slope of 0. So these are our critical points. So now what do we do with them? Back to this graph that is totally separate. I just wanted to use it as a visual aid to explain what we're doing in the other problem. So the reason we need to consider the critical points, or the points at which the slope is 0, and the endpoints, those are the important points, and where potentially those could be the points of the absolute maximum and absolute minimum values. So this is just a visual aid explaining what we're about to do, and yeah. So now we're back to our problem, and to find the absolute extrema, we just need to evaluate the function at the critical and endpoints, like I just told you. So we have our original equation here, And all we really need to do is take the critical points that we found, which were -2 and 1, and plug them back into this equation to get our y values, which could potentially be either the absolute maximum or absolute minimum values. And then we also have our endpoints, which are -4 and 2 from our interval. So we plug them all into this equation, and we got -2 at that point. We have our absolute maximum value, which is 24. And then as our absolute minimum value, one of our endpoints, we got -28. So those are our absolute extrema. And that's just a basic optimization problem. It gets a little bit more difficult if you expand the interval, or there's a lot more factors that come into play later, but that is the basic idea of optimization.